So the first thing we want to do is we want to learn what the IP address of our Kali machine is since we've just plugged it into our victim network. So let's go to the terminal. And because this is a Linux machine, we're going to use ifconfig. And you can see here that we got the IP address of 192.168.56.102. Now the network mask is 255.255.255.0, which tells me that the scope on this network is a Class C with 254 IP addresses. So it goes from 192.168.56.1 through 192.168.56.254, with the broadcast being reserved at 255. That's good information to know as we move forward. So the next thing we want to do is we want to bring up ZenMap. And to do that, you're simply going to type in ZenMap from the command prompt. And to make sure my command prompt is still available for me to use afterwards, I'm going to hit the and sign, which means it's going to run it in the background. So now ZenMap pops up and we can start doing our scans. The first scan we want to do is the least intrusive, so we can figure out what machines are on this network. To do that, we're going to do a ping scan. Our target for this network is going to be the entire network. So I'm going to use 192.168.56.0/24. That will tell me that I want that entire subnet. Now, another way you could write this is we can actually say 0 to 254, which would be all of those addresses as well. But in our case, I would like to use the CIDR notation of /24. Now you'll notice here in ZenMap that we actually get the command line syntax for nmap right here shown for us. So ZenMap is going to use nmap to do the work for us, but then it's going to take that detail and bring it back to us in a graphical format. Now, right now our profile selected is the intense scan, and that's going to be way too intensive for what we're trying to do. So we're going to go down and select a ping scan instead. Notice that the ping scan is just -SN and the IP address range that you want. And now I'm going to click scan. Now here in this main tab, I'm going to make this larger for us. Now here in this main tab, what you'll notice is you're going to see the results that nmap would provide you. In our case, all we did was a ping scan, so it searched 256 IP addresses and it found 4 of them that were up. Those 4 is the server, the DHCP server we set up, one of our virtual machines, our second virtual machine, and then our Kali Linux box ourselves. Now we don't necessarily know what these 2 machines are at this point, we just know that they're up and taking requests. But since we do know that 102 is our own machine, we don't need to scan that one anymore because we don't need to attack it. We want to attack these other 2 machines. So what we're going to do is we're going to take it a step further. And we're going to start doing different scans as we can gather different information. Now if you notice, if I click on the ports and host tab, there's no ports yet because we haven't scanned any ports. We've only done, is this machine up or down? But here we can see in the topology our network, and you'll see that there are 4 hosts connected. And we can also do a fisheye that makes it a little bit easier to see. You can see that we do have 4 hosts on the network. We have the 3 machines plus the 1 DHCP server. Now if we look at host details, all we know is the status that it's up. The only reason we know that is because it did a ping. We haven't scanned any ports yet. This is important to realize. So let's go ahead and go back to our nmap output and let's try a more intensive scan, but only targeting it to the 2 machines that we want to look at, which were 100 and 101. And from here, we're going to do what's called a quick scan. Now if you notice here, the quick scan is going to do some of the most common ports for us and find what information we can about this. So let's go ahead and do a quick scan. So here's what nmap would have given you if you were doing this in the command prompt. The scan report for 101, and if we look at 101, you'll see all of these ports are open. That is a lot of open holes that may be vulnerable for us to do exploitation later. Now if you notice that 192.168.56.100, all the ports were filtered. Now that's interesting to note because that one was actually our Windows machine, so we're going to have to take a look at that machine later as we go forward. But with the quick scan, we have identified that this 101 is a very vulnerable box. And that was our Metasploitable virtual machine. Now, if we look through it, we're going to see some port numbers, and those ports are going to be important to help us identify what this machine is. So as I look through it, I see that we have FTP and SSH and Telnet. Those are common to Windows and Linux. But the ones that aren't are things like RPC bind 111, this 139 and 445, Those are common of Microsoft and Windows machines. Notice though that there's not a 135, which is another NetBIOS port that's commonly seen on Microsoft. So what this is telling me is that this machine, which I think is Linux, is running some Microsoft services, and they're probably running Samba to do file sharing with Microsoft. If it had 135, 139, and 445, I would assume it's a Windows machine, but we're going to be able to determine it later when we do our enumeration. As we keep going on, we'll see the login and the shell, again, very common Linux things. We also have MySQL. We have a VNC player and X11. X11 is an extremely common Linux thing, so that again is one of those things that tells us it's probably Linux. Now if we click on the Port and Host tab, there's actually an easier way to see all this information. So if I click on the host I want to look at, and I click on the Port and Host 101, you'll see that I have open and closed states. In this case, all these were open ports that we're looking at, the port number and the FTP. So it makes it a very easy to see graphical representation. Now if I click on host details, it doesn't know what type of host this is yet, but it did find that there was 82 closed ports and 18 open ports. And we did look at 100 ports, which was pretty noisy of us. You can see under scans, this is the history of the scans we've done before. We did our ping scan, and now we've done our quick scan. Now if we want to get a little more intrusive, we can do what's called an intent scan. And what we're going to do is do an intent scan, and then we're going to hit scan. Now, the intent scan is going to look at the open ports and the closed ports, and it's also going to try to do some basic enumeration for us to try to figure out what this machine is or isn't. So in our case, we're looking at it. We're doing a stealth scan right now. You can see that. And this scan will take us a little bit longer because it's going through a lot of information. One of the things it does try to do is it tries to do an OS detection. It was unable to do an OS detection of the .100 system. Again, with the text-based information, it's going to give you a lot of information, and we can go through each of this individually if we want, but all of this is going to be shown in a much more graphical format for us to use as we move forward. So let's go ahead and go over here to the ports, and then click on the host. If you notice over here, our OS changed on the .101 machine, that metasploitable machine. If you'll notice, we have a little Linux icon here. We now see all of the open ports again, but notice the difference here from before. Not only is it FTP, but we know that it's VS FTPD version 2.3.4. This is that enumeration piece. You'll see that our Apache is version 2.2.8. You'll see that they were running Samba, which again, Samba Debian is a Linux version of file sharing to allow it to share with Windows workgroup users. So our guess of this being a Linux machine did pan out to be right. In this case, we have MySQL version 5.0.51. And again, these are all important to know because we can take this information and search the CVE database and be able to find out what known exploits there are for these particular services. So this is all part of that information gathering stage for us to plan our attack. And then we're going to move further down. You'll see here we have a metasploitable root shell. We have IRC channel, Unreal IRC daemon, and again HTTP with a Tomcat Coyote JSP engine on Apache. So we also have another FTP up here on port 2121. So lots of different things that we can go after as we start attacking this machine later on. Now let's take a look at that Windows machine we had. And you can see here no ports were identified. If we click on host details, it was unable to identify the fact that this was Windows. And if we go to Linux, you'll see that this not only was able to figure out that it was Linux, but that it's most likely Linux 2.6, somewhere between version 9 and version 33. That's going to go, and it gives us an accuracy used based on the ports that it saw. So based on what ports it had and the responses it received from those, it's able to tell us with 100% accuracy that this is Linux 2.6. It also does this based on TCP sequencing. In our case, it didn't do a very good job of it. It also can do this based on IP sequencing. Our case, it didn't collect any of that. And again, more TCP sequencing. And then we have some comments that we can look here in the bottom. There were no comments. So based on the ports used and the way that it responds, it understood that this was Linux with 100% accuracy. So it did a lot of that enumeration for us. Now, Windows has not been responding. Let's go take a look at our Windows machine and see why that is. Let's go into our control panel. We'll go to our security center. So you'll notice the Windows firewall was on. We're going to go take a look at the Windows firewall and see if that's the reason why it's not responding to us. So in this case, we have the firewall on, and the only exceptions are the ones in the exceptions tab. If we look here, there wasn't a whole lot of exceptions. If you notice, file and print sharing was not an exception. Let's go ahead and let that be an exception right now, because most home networks are going to use file and print sharing to be able to share files and printers across their network. And then let's hit OK. Now let's go back and try our scan again. So now that we've set the exception in the firewall, we're going to scan the Windows machine again using that quick scan. That's going to do the 100 most common ports. So we'll scan that machine. And you can see now, because we've opened the Windows file sharing and allowed that exception, that we can now identify port 139 and port 445 as part of that machine. Now if we go to the host details, let's see if we can figure that out. We still can't figure that out yet. So we're going to have to do a more intensive scan. We'll go back here and do an intent scan on 100, just the one machine, and we'll scan again. Now it's discovering the open ports on 139 and 445. It's going to do a SYN stealth scan to try to be a little bit sneaky for us as it goes through 1,000 commonly looked at ports. Now if they happen to be looking at this network traffic, they're probably going to see this, because going port 1, port 2, port 3, port 4, and going all the way down, you're going to end up seeing something. The other thing, because this is an intent scan, it's actually using 138 specific scripts as it goes through and does this. This is how it's able to do things like the enumeration for us. Figuring out what ports were open is fairly easy with a scan, but now it's actually going to use those different scripts. It's going to see those open ports, and based on the way it responded from each of those ports, we're going to be able to determine what version of the operating system it's using. So as we scroll up here in our text, we can see some information that was found from the scripts. Again, port 135 and 445. We believe it's Windows XP based on the way it responded. We also get the MAC address, and based on that MAC address, we know it's a virtual box. In this case, we also can see the operating system scan was unreliable because they couldn't find at least one open and one closed port. They only found those open ports. The firewall blocked the rest of the ports from us, but they believe that it's Microsoft 2000 or XP. Now, why would it be 2000 or XP? Well, Microsoft XP and Microsoft 2000 share a common code base. Just like Windows Vista and 2003 share a common code base, Windows 7 and 2008 both share a common code base, 2012 and Windows 8 also share a common code base. So as they move forward in these, you can start seeing this overlap, and you'll a lot of times get one where it thinks it's one or the other or both. Now in this case it did a fairly good job. It realizes it's either Windows XP Service Pack 2 or Service Pack 3 or Windows 2000 Service Pack 4. In this case, it wasn't able to do the prediction through TCP sequence, but it can do it based on the information received from the port scans. Now as we scroll down, we had some enumerations run as well. In this case, it did a NetBIOS check. It found the name of the computer. The name of the computer is John's PC. It also gave us the fact that he's in a work group, not in a domain. We also know the fact that we're still, again, using Windows XP based on SMB that we found. SMB being the file sharing. And then it did a trace route. In our case, the trace route goes immediately there because we're on the same network. After it did all the scanning, it runs through a couple of other different reports and scripts, tries to find as much information as it can, and it did all of that scanning in about 50 seconds for one host. This is important to know because if you're doing an intensive scan, it does take some time. This was on a network that was on the same network on the same machine, meaning it was very quick. If I had to go all the way across the internet to another host, and I was scanning numerous hosts, that time goes up. The more time you're spending, the more packets you're sending, the more likely you are to get caught. In our case, we sent out 2,035 packets, but we only received 15 back. So the chances of us getting seen was 2,035 times that we sent information to them. There are ways we can be a little bit more sneaky with these tools. It just depends on the profiles we use and the way we configure them. Now, as we go into ports and hosts, and we click on our Windows tab here, the .100 machine, you'll see the fact, again, based on that text output we had, in a nice graphical format that we can see. We then go into topology, and we now see that there is some sort of a lock on this, meaning that there was a firewall or some sort. and then we're going to go here to the host, and here we can see that we scanned 1,000 ports, and of those only 2 were open and 998 were filtered. Filtered means that there was some sort of firewall there blocking us. Again, the accuracy, the fact that we are Windows 2000 or Windows, very accurate in this case, and they do that based on the port that they saw. The one they made their decision on was 139, which was a NetBIOS file sharing. And the class is Windows 2000, and as I said before, Windows 2000, Windows XP share a common code base. They answer up the same way, so they look very similar in traffic. So, as you can see, we can be very invasive or very quiet in our scanning techniques. It really depends on the level of information that we're trying to gather. The question now becomes, how quiet do you want to be in your hack? Well, that's going to depend on why you were hired by the organization in the first place. Are they looking for a realistic hack to challenge their defenders and find their weaknesses? If so, then you would want to be very, very quiet to give them a realistic threat. But if you were tasked to provide the defenders a simple emulation of an adversary of a script kiddie, you'd want to be really noisy. And that way they can find you quickly and take you down. It really depends on the intent of the assessment. Again, these tools can be used very sneakily, do the customization, or very loudly. It all depends on how well you understand your toolset, your intent, and your method during the hack.